What is regeneration in the Rankine cycle? Imagine a power plant trying to get the most energy out of every drop of fuel. One clever way it does this is through a process called regeneration. This process helps the cycle use heat more efficiently. In the basic Rankine cycle, water is pumped into a boiler, heated to turn into steam, and then expanded in a turbine to produce electricity. Afterward, the steam cools down in a condenser and turns back into water. But there's a way to make this process smarter and save fuel. That's where regeneration comes in. It involves taking some steam from an intermediate point in the turbine, after it has expanded a bit, and using it to preheat the feedwater before it enters the boiler. This extra step means the feedwater is already warmer when it reaches the boiler, so less heat is needed to turn it into steam. Think of it like warming up water before boiling it, so the boiler doesn't have to work as hard. This process is done with special devices called feedwater heaters. Sometimes, the steam used for heating is mixed directly with the feedwater, called an open feedwater heater. Other times, it transfers heat without mixing, called a closed feedwater heater. By preheating the water, the cycle reduces the amount of fuel or energy needed to produce the same amount of power. This makes the whole system more efficient and saves money. In power plants, the turbine is often split into high-pressure and low-pressure sections. Steam is extracted from an intermediate point in the turbine to feed the heater. The pressure at which the steam is taken out is carefully chosen to get the best efficiency. This process is especially useful in large power plants where saving fuel and reducing costs are very important. It allows the cycle to work closer to its maximum potential without needing super high temperatures or pressures, which can be expensive or hard to achieve. So, in simple terms, regeneration in the Rankine cycle is a smart way to recycle some of the energy in the steam to warm up the water before it gets heated again. This reduces the fuel needed and helps produce more electricity with less waste. It's a clever trick that makes power generation more effective and economical.